take that as a no. So let me open up something else that I want you to copy. So let's write this down and then I'll explain you what we wrote. All right. Does anyone need more time? So UML. So what is UML? UML stands for Unified Modeling Language. Now what happened was that when the IT world started, if a BA had to show a use case, one BA would create a rectangle and type login and would say, anytime that I type, when I draw a rectangle, that's a use case for me. Another BA would say, anytime when I draw a triangle, that's a login symbol for me. So what would happen is different BAs would end up using different elements or different notations to show the same, and people would end up getting confused. So what happened then is IBM came up with a language known as UML, which stands for Unified Modeling Language. So unified is one, modeling is the way you draw, language is the way you represent. So it's one common language of drawing, and that is UML. So now nobody can just come up with notations that they like. Instead, they have to follow the notations which are prescribed in one of the 9 different diagrams. Now, we as BAs, we end up using the first 3 diagrams, which is the use case diagram, the activity diagram, state diagram. The remaining diagrams, which are in red, sequence, collaboration, class, object, component, deployment, they're all technical diagrams, which we don't create. So we stay away from that. So we'll concentrate on the first three diagrams, which are the use case, which is the use case diagram, the activity diagram, and the state diagram. So today we are going to start learning the first diagram, which is known as an activity diagram. So let's write down the definition of an activity diagram. The definition is an activity diagram is used to show a business process workflow. An activity diagram is used to show a business process workflow. So let's understand what are the different elements that are used to create this diagram. So it consists of a dot like this, and this dot represents start point. You use a rectangle with rounded corners, and this box is used to denote an activity. It consists of a diamond shaped box, which is known as a decision box. Consists of a bar like this, which is known as a fork or a synchronization bar. Consists of rectangles like this, known as swim lane, and consists of a dot with rounded circle, known as endpoint. So these are the different elements. Now let us see an example of an activity diagram. All right. So what you see here is it's how an activity diagram looks like. Now, what is a common name that we are used to be calling to such a diagram? We also call this, there is another name to this diagram which we won't be using at work, but it's a layman language. What do we call this as? You might have come across such a drawing before. What is it called?
A workflow?
A workflow. There's another common name similar to a workflow to this kind of a diagram.
Oh,
Come on, you're almost there.
the waterfall or something?
No,
Okay.
Sorry, I was wrong.
It might be process flow.
It's called a process flow, yes, but there's a very, very common layman language term that we have called it in the schools or colleges. It's called a flow chart.
Flow chart, yeah.
However, we never refer it as a flow chart. We always call it as an activity diagram. So what is this? The dot you see, what is it called here? What is this dot?
Start
Starting
point.
point.
That's your start point. This is your end point. This boxes with rounded corners, what are these?
Activities.
They're all your activities. The diamond shaped boxes, what are these boxes? Let me blow this up.
The decisions.
Decision box. So this is talking about, are you seeing a box on the screen? Because I'm seeing the participant list which is right in the center. Do you see that, or it's transparent to you?
No, it's visible.
It's transparent, right? Or you see the participant list on the center of the screen blocking your view?
No, no, no.
You cannot, right? Okay, good.
Yeah.
All right. So this is a sales flow. It's a process flow of a sales team. So what are they doing? Number one, prospect clients. Then there's a decision. After they talk with the clients, is there an opportunity with the client or not? If opportunity does not exist, they just close, saying, you know what, this is useless. It's not going to work. If the opportunity exists with the client, you qualify the clients, you gather the campaign information, you approve their credit. Is the client ready? If it's not ready, you still wait until all these things are done. If the client is ready, you enter the data in the system. Is the data approved? Then you propose campaign to the client. If it's not approved, you re-enter and modify. So that's what a decision box is. It is a yes or a no scenario. What are these boxes? What are these lines? The two lines that you see here.
Could it be like all three of them are contingent to one another, or they can be
What
worked on simultaneously?
what are these known as, these lines?
Barriers? Oh, something
These
like that. I
are
forget
known
what it
as
was.
fork or synchronization bar. These are known as fork or synchronization bar. And what it suggests is it shows me activities which takes place in parallel simultaneously. Over here, see, close the deal, initiate IO process, review campaign details. What happens first? Close the deal, then initiate, and then review campaign. How do I know this? Based on the direction of the arrow. What if I want to show that close the deal, initiate IO process, and review campaign details, they all happen in parallel? Then I can put them in a fork or a synchronization bar. So any activities which are in fork or synchronization bar, they always happen in parallel at the same time. That's what that means. Any questions? All right. I'll show you another flavor of this. All right. That's another diagram. So what is it? What is difference that you see here from the previous one? So you saw this one. Now I'm showing you this one. What is the difference in the two?
Looks like there's different stages. Like one is the customer stage, and then the PMI stage, and the prometric stage.
Super. So basically you see that the entire diagram is divided into three different sections, right? And each of the section is nothing but it's a swim lane. So what is the significance of this swim lane customer? Why have I divided? What is it that it's trying to show? What is the significance of I dividing it into three different sections? What is it showing? Why do I call this customer? And why do I not call this PMI?
There are actors identified.
Super. So all I'm trying to do is I'm trying to divide the entire diagram based on the actor. So I'm saying any activity or any decision which is in this lane, customer is the actor for that. Any activity or decision in this lane, PMI is the actor for that. And Prometric is the actor for anything which is displayed in this. So this is a swim lane. So it's not a very common thing that we always use swim lanes. It just complicates the diagram. But we may be using swim lanes to separate the actors, separate the activities and decisions by the actor. So let's write it down. An activity diagram, an activity diagram may also be referred as an activity diagram may also be referred as a swim lane diagram. We'll write another sentence. Swim lanes are used to divide swim lanes are used to divide an activity diagram via actors. Next sentence. And decision every activity and decision documented in the swim lane every activity and decision documented in the swim lane is executed by the actor is executed by the actor displayed in the swim lane.
Displayed in?
In the swim lane. All right. So when do we use these activity diagrams? So activity diagrams are more like an add-ons to your documents. So anytime you write your FRD or you write your use case, you can also create an activity diagram to show and to help the users understand how the process works. So these are not mandatory diagrams, but they are very, very useful diagrams to help the audience understand what the future business is going to be. You can also create activity diagrams to document the as-is business processes when you join the project. So let us see how to create one. So just before an hour, we created the use case for login. So what is a use case? A use case is nothing but it's a process flow. So I could also convert my use cases into an activity diagram so that it becomes easy for everyone to understand. So let us see how to do that. So if I want to convert my login use case into an activity diagram, I start with a dot every time, which is my start point. Then I want to create my first activity. So what is step one? What do I write here? What is the first activity in that login use case?
It's enter user ID.
Okay, so I'm going to say user enters user ID. So I create an activity and I connect here. What happens next? What is the next activity?
User press the continue button.
Okay, user clicks continue button. That's my next activity. What do I write next?
System validates the user ID.
That is again an activity. System validates user ID. I just want you to concentrate for now and I'll give you enough time to copy this. Alright, now I'm more interested as to what happens next.
The system has to make a decision whether it accepts it or not.
Perfect. So how do I display that here?
Is it the diamond shaped box?
Okay, very nice. Do I write something in the box? What is the question I type in the box?
If it accepts the password, the login, the username.
Alright, I'll give you another minute to decide whether it's the password or the login or the username.
The user ID.
Perfect. We are talking about the user ID here.
Yeah.
What is the question do I ask?
Is the user ID valid?
Perfect. So that's the question. So I'm going to ask a question. Is the user ID valid? So I always write my question next to the decision box. What are the outcomes of that?
If valid, then it will go to the password page.
So if it's valid, so I'll say system displays password page. So what kind of scenario, do I write anything on this arrow here? The arrow that's coming out of the decision. Do I write anything on that? On this arrow? Because I've asked a question here, is the user ID valid?
So we can write valid over there.
Okay, so I could either write valid or I could simply say yes. Because I asked the
Yes,
question, is the
okay.
user ID valid? So I say yes. What is my no scenario? What happens in the no scenario? So,
System displays the error message.
okay. So I can say system notifies the user of invalid user ID. So this is my no scenario. What happens after this here?
It will again take back to the first page, user ID, enter user
How
ID.
do I show that?
With the arrow. on the first stage.
So I simply connect this to this.
Back. Okay. Mm-hmm.
Okay, so this is my AF1. Got it? Alternate flow 1. Over here, system displays the password page. What happens after this?
The user will need to enter the password.
Password. What happens next?
User clicks login button.
Next,
Next is decision by the system.
system validates.
Validates the password.
All right, what next?
The diamond shape. Yeah.
Mm-hmm.
What is the question that I ask?
Is the password valid?
All right. If yes, what happens?
System redirects to summary page.
System displays account summary page. What happens next?
If no,
No.
then
After system displays account summary page, what happens next? Nothing. My use case, it's over, so it's an endpoint. Get it?
yes.
All right, now I'm more interested in the no scenario. Let's talk about that. What happens if the password is not valid? Think and answer.
First, it will count the number of attempts.
So again, it's an activity, correct?
Yeah.
System calculates password failure count. All right. What next?
If the attempt is less than 3, then it redirects
So
to.
then what happens? What comes after here? What do I write next? That's what I'm asking.
If it's wrong, it's gonna go back to
Nope. System calculates the password failure count. What happens after calculating password failure count? You're missing something. You're missing. So after you calculate the password failure, is there only one outcome or there's more than one outcome?
Decision. Yeah.
Exactly, right? So every time you have
yeah.
one outcome, you simply put a decision. That's what I want you to understand.
Right.
What is the question that I ask in the decision?
If the attempt is less than 3.
Is the password failure count less than 3. Okay, so what are my options?
Yes.
So if yes, what happens?
System displays account summary page.
No, if the password failure count is less than 3, what happens? It does not
It
display.
will ask to again enter the password.
System notifies user of. It shows the error message that your password.
So
What scenario is this? This is the yes scenario. And where do I connect that box to? This goes where?
user enter password.
Perfect. Simply goes here. What happens to the no scenario?
It will connect to end.
Not
Or
really.
okay, account locked for let's say 24 hours or something.
System locks the account. And then where does this get connected to?
To the end.
That's a complete activity diagram. Easy.
Okay, sure.
I'm going to show you the same diagram in a compact format. So I want you to copy this if you haven't yet copied. Alright, so this is the complete diagram that we just went through. So just go through this and copy this. All right, any questions? Okay, I think that's all I wanted to cover for today's class. Tomorrow again we'll start sharp at 10 in the morning. Um, before I close off, again, any questions that I can answer?
Can you please show me again? I'm sorry, I'm missing the last part.
Sure. You see that?
Yes, 1 minute. Thank you.
All right. Okay, any other questions before we close? All right, so then I want you to copy this. So I want you to take 5 minutes, copy this down in your notes, and we are going to discuss this. All right, did you all get a chance to copy this, or does anyone need more time? All right, so I assume all of you have finished copying this. So my next question is, what kind of diagram is this? What kind of diagram is this?
Flowchart.
It's a flowchart, so it looks like an activity. So let's talk in the BA language. So what kind of diagram is that? We don't call it a flowchart. What is the name that we use?
Activity design.
This,
Activity diagram.
yes, it is an it looks like an activity diagram. Why? Has a start point, has an end point, has activities, has decisions. Now, my next question. What is it trying to show you here, this diagram? What is it trying to show you? What?
It seems like
Application
it's
started.
an application. Yeah, application development stage, I guess.
Not an application development stage. Someone else was saying something?
Process flow.
It is not showing me a process flow. It is not.
The application start and stop. I mean, it's the opening of the application.
It is not showing me the opening of the application. Think again. Look here. Application stat.
It looks like an application for a test, like an exam.
Very good. So it is talking about. So this is mainly, let's say you heard of a PMP certification, right? So when you apply for a PMP exam, these are it's talking related to that. But my question is, it is showing me something about an application process. But my question is, what is that something that it is showing me about that application process? What is that something that it is showing me about that application process? Look at this. Application status in progress, application status submitted, application status in review, application status ready for exam schedule. So what is it trying to show me? It is trying to show me all the different states that a particular process has. It is showing me what are the different states that the application has. So the moment you submit an application, the status becomes in progress. The moment it is selected for, the moment you start filling up an application, it becomes in progress. The moment you submit, it becomes a submitted status. The moment you're selected for a review, it becomes under review. And then from review, it becomes ready for exam schedule or rejected. So it is showing me all the different states of a particular process. Although it looks like an activity diagram, this is a state diagram. It's a state diagram. So let's write down the definition of a state diagram. A state diagram a state diagram is used a state diagram is used to show all the potential states all the potential states that a particular process can attain as well as as well as as well as shows the conditions as well as shows the conditions that transitions one state to the other. All right, any questions on the state diagram? Do you understand what I'm trying to explain here? Next question. If you had to create an activity diagram for this process, what would your activities say in this diagram? What would it look like? Can anyone think and tell? I want you to understand the difference between an activity diagram and a state diagram.
So in activity diagram, first it will be the start point, and then user starts the application will be the first step.
Very good. So step one would be user clicks on new application. What
New
would be the next,
application,
what
yeah.
would be the next step?
Then next step will be user submits the application.
No, so the next step would be system displays the application page.
Right,
And
yeah.
user enters data.
User enters the data, yeah.
Right? User submits the data, submits the application. System validates
Right.
the data. If everything is valid, it goes to the review queue. Somebody picks the application
Right.
for a review. Then they either reject the application or they select the application and then it goes to the exam schedule queue. So it talks about the process flow. That is the activity diagram. Versus the state diagram does not talk about what actions is the user taking to complete the process. It does not talk about that. It only talks about what are the different states of this process and talks about what condition changes one state to the other. That's a state diagram. I hope this helps clarify. Now, if you still are not clear and if you don't ask me questions, then I would not know that you don't understand this. So if you don't ask me questions, I would assume that you understand this. All right. Now, state diagram, it's pretty much an overkill to create, and it's not a very common thing to do at work. However, it's one of the diagrams that we use, so you should just be aware about. So remember yesterday we talked about Yesterday we talked about activity diagram. Today we talked about state diagram. What we have not yet done is the use case diagram. Now, so let's write down the definition of a use case diagram. A use case diagram a use case diagram shows the interactions between the actors and the use case as well as as well as shows the relationships between as well as shows the relationship between the use cases. All right, so let us understand this. So it shows two things. It shows the interactions between the actors in the use cases, and it also shows the relationships between the use cases. So when we talk about a use case diagram, what are the elements we use to create a use case diagram? So use case diagram consists of a symbol like this that represents a use case. So if I want to show a use case and want to say this is a login use case, I use a symbol, it's called an oval symbol. So we create an oval and we write down login. So whenever you want to show a use case, you use an oval symbol and you write down the name of the use case inside. So this is how we represent a use case in a diagram. This symbol is used to show an actor, represent an actor. If I want to show that the name of the actor is a teller, I create a symbol like this and I type a teller underneath that. So this represents an actor who is a teller. And the third element we use here is system boundary, which is a rectangular boundary like this. I don't want you to put the top rectangle, it's only a rectangle down here. You write down the name of the boundary on the top, and I'll explain you what a boundary means. So use case diagram has three elements in them. The first element is it has a use case, which is represented with an oval like this. The second element is a teller, which is represented like this. And the third element is a system boundary. All right, so now I'm going to erase this and I'm going to show you how to create a use case diagram. So if I want to create a use case diagram, the very first thing I want to do is I'll create a system boundary. So if I'm creating this diagram for ATM, the name of my system boundary is going to be ATM. So what I'm trying to explain you here is a system boundary is used to represent the system for which you are creating the diagram. So this boundary is representing your system. So a system boundary represents the system for which you create your diagram. So if I'm creating this for ATM, my boundary will say ATM. The next thing I want to do is I then want to add use cases inside the boundary. So what are the use cases for ATM?
Withdraw. Detail. Use
So check balance and view account is almost the same.
deposit.
Some of the use cases. So why have I kept my use cases inside the boundary? What is my boundary? My boundary is representing the system for which I'm creating the diagram. Now, my use cases are always a part of the system. They're always inside the system. So I create my use cases always inside the system. Then I identify who my actors are. Now my actors are always outside the system. So one of my actor is bank customer, and my second actor is guest customer. What is the difference between a bank customer and a guest customer?
Bank customer already on account. Bank customer belongs to that bank. Guest customer belongs to some other bank. Which is
So let's say you are a customer of Bank of America and you are accessing the ATM of Bank of America. You are a bank customer. A guest customer is you have an account with TD Bank and you are accessing the ATM for Bank of America. So you are a guest customer. What do you do then is you go through each of the use case. All right, so you go through each of the use cases and you want to start identifying who is the actor for what use case. Login. So who can log in? So I'm going to connect both. Who can deposit funds?
bank.
Only the bank customer can. Who can withdraw funds? Who can transfer funds? Only the bank customer. Who can check balance? Both of them? Okay. All right. So what I'm doing is I'm showing the interaction as to who interacts with what use case. This is the first part of the definition which says a use case diagram shows interactions between the actors and the use cases. Now I'm going to add another use case, and the name of this use case is ATM maintenance. So this is the use case wherein someone will log into the ATM, will remove all the deposited checks, will add more cash, things like that. So who is the actor for this use case? Someone from the bank. So I'm going to create another actor here. I'm going to give the name of the actor as an ATM admin. Now, this ATM admin also has an account in the bank and also is using the ATM for checking balance, depositing funds, transferring funds. Does it make sense for me to connect this ATM admin with the remaining use cases?
No.
Why?
Internal control, each prospect, whether he'll steal or you check or. Because if it's a customer, then it's already connected from the customer side.
Correct. So basically, whenever this guy is accessing the ATM to deposit his funds, how does he log in? Does he log in with the credentials of an admin? He logs in with the credentials of a customer. So he no longer is an admin, then he becomes a bank customer. So all I'm trying to make you understand and realize is actors are role based. The same person can play multiple actors in the system based on how they log in into the system. Simple. So actors are not human based, actors are role based. And the next thing we want to learn is an actor can be a human or an actor can be a system. An actor can be a human or an actor can be a system. What does this mean?
Like the bank mainframe would attach the ATM to know what the balances are, to be able to see what's going on in the ATM. That
No.
Like the color system, that's an actor.
No. Deposit funds, all right? This use case. How does this use case begin for an ATM machine?
somebody selects it.
Somebody selects it.
Mhm.
So who's that somebody? A human.
Mhm.
Transfer funds for ATM. How does this use case begin?
Same thing.
Somebody selects it. Who's that somebody? A human. So use cases in which an actor is a human, those use cases are not triggered automatically. They have to be manually triggered by a human. A human actor says, I want to do this. On the other hand, the use cases where an actor is a system, they're triggered automatically by systems. There is no human intervention. So those are all automated functions. What's an example of an automated functionality?
The ATM like locks up when it's down.
No, but that's a response. Yeah, ATM locks up when it's down. That's a perfect example. If something's wrong in the ATM, system auto. So lock ATM if something's down. That's a perfect example. Alerts. Whenever you receive text alerts, email alerts, they're all automated functions. So anything which is done automatically without a human intervention. Recurring transfers. What are they? Automated functionalities where the actor is a system.
Triggered by human, and they want to enter the information that.
So there are two use cases to that. The first use case is set up recurring transfer. So the human logs in and they say on the first of each month, I want to transfer $500 from account A to account B. So the human is an actor for that. The second use case is execute recurring transfer. What happens in that? What is the precondition for execute recurring transfer?
It's been set up already.
It has been set up. What is the trigger to that?
When is the first of the month?
When is the first of the month, right? And what is the post condition to that?
If you don't have it.
No, the post condition is whenever the transfer is made,
Oh,
you notify the user via an email or a text message that the transfer has been complete. So those are automated functionalities.
how about, for example, right, if the guest customer is trying to make a withdrawal and the guest customer is told that when you go to another bank and it tells you that you're gonna get charged a fee.
But that is again a part of your withdrawal use case, withdraw funds use case, or you can write down whatever.
That's not automated
No,
because
no,
we
no.
still trigger it.
Yeah.
by being a
Yeah,
guest customer.
yeah. So this talks about the first half of the definition, which says a use case diagram shows the interactions between the actors and the use cases. An actor can be a human or an actor can be a system. The second half of the definition says a use case diagram shows relationships between use cases. A use case diagram shows relationships between use cases. So when we talk about the relationships between use cases, there are two relationships which exist between use cases. Number one is known as includes or uses, and number two is extends. So we'll first start understanding the first relationship, which is includes or uses. I want you to write this down. So let's say for Expedia, before you write down, let me just explain you what this is. Let's say for Expedia, there are 3 use cases that we have. Book a flight, rent a car, and book a hotel. Now what I'm writing here is the flow of each use case. In order to book a flight, you search a flight, you view results, you select a flight, you enter passenger details, you enter payment details, and you confirm the booking. But what I want you to understand and imagine is that I'm not writing a detailed narrative here. I'm not writing a detailed use case. I'm only writing high level points. So I want you to imagine that every point that I write here, I can break it down into 5 detailed steps if I'm writing my real use case. I'm rolling up my steps here just to explain you something else. So if this has 6 steps, and if I can roll it down into each step is equal to 5 steps in detail, this use case will have about 30 steps. This use case will have about 35 steps. Again, this use case will have about 30 steps. Are you following what I'm trying to say? I'm just saying that let's imagine there are 3 use cases and I'm writing down just some high level steps of how to do this use case. But had I written my real use case, each step I could have written down into 5 detailed steps. So I want you to take the next 5 minutes and write this down, and then I'll explain you what we want to do further with this. All right. Everyone finished? Anyone needs more time? All right. So what happens is that once I finish writing my use case, I give it to my coworker for a review. I say, why don't you have a look at this and see what do you think about these? So when my coworker is looking at these use cases, they come back to me and they say that for each of these three use cases, there is one step which is a high level function which is exactly the same in all the three use cases. And I'm writing the same thing again and again and again in all the three use cases. So what is a use case? A use case is a function. So what my coworker says is each of this use case consists of another sub function which is exactly the same in all the three, and I'm writing it again and again and again in all the three use cases. So let us understand what is he or she talking about. So is searching for a flight the same as searching for a car, the same as searching for a hotel? Yes or no? You enter different information to search. So when you look at a function, you want to talk about not only what the user can do, but the user interface as well. Are the results displayed the same way for a hotel or a flight or a car? They're different. They're displayed in a different format. Selecting is not even a function. Do you enter the same details when you're trying to book a flight or a car or a hotel? Different. Do you enter the same data when you're trying to pay for flight or a hotel or a car?
Yes. For the most
Does
part.
not matter what you do. This is for Expedia.
But it depends, because in some, like say you get insurance, the WDI waiver,
I'm talking about the payment.
payment, yeah, I'm from the payment also.
So the way you are taking the payment, when you take select an insurance, it increases the price.
No.
Raj, so I'm trying to explain you a concept and not what actual company does. So let's understand from that perspective. So assuming that the way you do a function is exactly the same in this use case, that use case, and that use case, there is a common sub functionality. Then rather than writing how you take payment again and again and again in all the three use cases, a smarter idea is you create a use case number 4 which says enter payment details. So what you're doing is you're trying to identify that there is a sub functionality which is same here, here, and here. So I come up with a fourth use case called enter payment details. And once I've done this, what I do is I'm going to modify my previous steps. Rather than I will remove all the steps where I wrote how to take payment. Instead, I'll say Okay. So can I say that use case book flight includes enter payment details? Use case book flight includes use case enter payment details. Use case rent a car includes use case enter payment details. Use case book hotel includes use case enter payment details. That's an includes or a uses relationship where one use case includes another use case. By creating this, what I'm trying to do is I'm trying to tell the developer, you write a piece of code once and you can copy and paste the same piece of code here, here, and here. It's the reusability of the code. So let's write down the definition of an includes relationship. An includes is a relation. An includes is a relation wherein it's a relation wherein the sequence of flow of one use case is included in the sequence of flow of another use case. An includes is a relation wherein the sequence of flow of one use case is included in the sequence of flow of another use case. So let us see how to show this relationship in a use case diagram. So I'll again, what will be the name of my boundary in this case? What is the system for which I'm creating this? Name of the system, not the name of the use case. Expedia. My use case names are
Book flight, rent a car, book hotel,
and I'll have my actor here that is an online user. So we know this much. Now I want to show that what is the relationship here? Does book flight include enter payment details or does enter payment details includes book flight? Book flight includes enter payment details. So the way I say is the way I draw the arrow. So I select here, I'll show you how to do it tomorrow in your laptop. There is an includes arrow here. If I say book flight includes enter payment details, I start my arrow from book flight, take it to enter payment. Similarly, rent a car include enter payment details, book hotel include enter payment. So let's create this relationship. All right. And then the last thing for the day is I want to show you the relationship which is extends. Mhm. Or if you can just give me 5 minutes, I'm done.
Oh, okay, all right, cool.
All right. So these are two examples of an extend relationship. So what do you think is an extend relationship?
It's not critical to the, it's an add-on.
It's an add-on. So it pretty much is an optional relationship. It's an add-on, but it's a one-time option. So when you're right, you'll get an option to purchase trip cancellation insurance. If you say no, you just cannot go to the website and say I want to purchase the insurance. You'd only be able to do this while you're trying to execute the main use case. Similarly, book flight, you just cannot purchase extended warranty by logging into the website. You only see that option while you're trying to book a flight. If you say no, you'll never see that option again. Now, why is it called an extend? The reason it's called an extend is, let's say you're trying to book a flight and you take 10 steps to book a flight. In the eighth step, they're asking you a question, would you like to purchase trip cancellation insurance? If you say yes, are you able to complete your use case in 10 steps? You take about 3 to 4 extra steps. So this use case extends the length of this use case. So it's called an extends relationship. So let's write down the definition. An extend is a relationship An extend is a relationship wherein the flow of one use case wherein the flow of one use case is extended by the flow of another use case. So that is everything you want to know for a use case diagram. So if you go back again to the first thing where I made you write the note, the definition of a use case diagram before an hour. The definition was a use case diagram shows interactions between the actors and the use cases. So when we talk about interactions, we learned that actors can be humans or an actor can be a system. And actors are rule-based, they're not human-based. The second half of the definition says a use case diagram also shows the relationships between use cases. So there are two relationships which can exist between use cases, include and extend. So that's everything that you need to know for this.